secant, and how do you say the other one? Yeah, it's right there. So that's what secant is. That's what cosecant is. Graph. Are these related? Yeah, because cosecant is 1 over sine. So that one's kind of easy because it's just sine theta. But we're going to get some that are a little harder. So first, let's graph that. How do we graph sine theta? What's the amplitude? 1. What's the vertical displacement? 0, right? What's the period here? Yeah. Huh? It's just 2 pi, right? So, period, remember this formula? Is 2 pi over b. What's b here? Yeah, so the period is 2 pi over 1, which is just 2 pi. Okay? And then what's the phase shift? Actually, okay, theta minus 0. There's nothing. That's what I'm trying to say. Kind of hard to write that in this with his A, B's, and C's and D's. Okay, so we don't care about that. Don't care about that. 1, 1, we don't need it. That's just good old, this is where we started. A sine wave starts there, ends there. The maximum goes up to 1. The minimum goes down to there. Halfway between there and there, it's 0 again. Nice and around. Goes through there. Nice and around. Okay. What's the domain of sine theta? Everything. Periodic motion goes on and on and on and on and on. What's the range? And again, I'm sorry, but range, like there's kind of 2 interpretations of range, and sometimes it's y from here to there, everything. And sometimes we're just going, what's the range of this thing from 1 to -1? 2 units. So we're kind of, I know we're kind of flip-flopping a bit. Preston? Yeah. Thank you. Yep, it should. Thank you. Okay. That's pretty ugly. Okay. Here, I want to say it's the values of y less than or equal to 1, greater than or equal to -1. Okay, that's the range. That is, in fact, 2 full units. X-intercepts. There's 1, there's 1, there's 1. So what are they? They're at 0, they're at pi, they're at 2 pi. Is that the only ones I have, though? No, there's infinitely many because this thing goes on forever and ever. So how can I write a little kind of a cutesy little formula to tell me where my x-intercepts are? Pi n. Yeah. Where what? N is a, yeah. So how can I write that? I can write that in English. N is an integer, or n is the set of all integers. Okay? So check it. Like n is 0 an integer? Sure. There's 0. 1, there's 1 pi. 2, that's 2 pi. Of course I got negatives as well, right? Okay, so that's it. So, cosecant. What does this thing look like? First, I'm going to tell you what I told you in grade 11, and then I'm going to say forget it. Okay? So, in grade 11, I said, what's 1 over 1? Okay, good. As this thing gets really, really, really close to 0, that's a really, really small number. What's 1 over a really small number? A really big number. So it looks like that. As this gets really, really, really close to 0, that's a really small number. What's 1 over a really small number? A really big number. Okay? That's math 11. What's 1 over negative 1? Because I'm graphing cosecant now, right? That's 1 over sine, well, it's right there. 1 over sine theta. So what's 1 over negative 1? Negative 1. As this gets really, really, really small, negative, like 0.0001 negative, what's 1 over negative 0.0001? Negative like 1,000 or 10,000. How many zeros was that? Okay, really, really big negative number. Same thing over here. So what's my range of the green graph? What's my range here? What are my y values? Well, y goes up to positive infinity and comes all the way down to 1. Y is all the values of greater than or equal to 1. And y are all the values less than or equal to negative 1. Just patience. Patience. What's the domain of this thing? Okay, well, what do we call these guys again? Remember where the original function is 0, I kind of told you to start there in grade 11. That's where we're going to have a what? An asymptote. Yeah, this graph, cosecant theta, will never get to these points. Those are asymptotes. My domain is everything in between these asymptotes. So it's, how do I say everything except 0, or except pi, or except 2 pi? I'm not going to say what it is, I'm going to say what it isn't. It's not equal to 0, pi, 2 pi, so on and so on. Have we kind of seen this before? X is not equal to n pi, or pi n, where n's an integer. It's good everywhere else, okay? Just not at those points where my original function was 0, because I can't do 1 over 0, restricted value. So where's my asymptotes? Pi n, where n is an integer. Okay? There, no good. There, no good. There, no good. And every pi after, and every pi negative before it. Okay? That's where the asymptotes are. So, you have a question, Lewis? Yeah. So, we're going to get a little more complicated with these graphs. All we need to do to graph this is find your maximum and flip it. Find the minimum and flip it. Okay? That's how you're going to graph this. So in this instance, I don't really like to say this, but don't try to figure it out. Just memorize that. We'll see on the next page what I'm saying. Okay? So, cosine. You know what that looks like? What's the period here? 2 pi. Oh, look. Starts at 1, goes all the way down, ends up at 1. Okay, my amplitude here is just 1, so it goes from negative 1 to 1. Halfway is my minimum, and in between my max and my min is a 0. Okay? Domain, all real. Range, less than or equal to 1, greater than or equal to negative 1. X-intercepts, There's pi. This is, remember, 90 degrees out of phase with sine. That's pi over 2. That's 1.5 pi over 2. Where's the next one? Half pi, 3 over 2 pi. Yeah, 1 and 3. See a pattern here? Add 2 over 2 pi, that's 5 over 2 pi. So on and so on. How can I write a little formula for that? Pi over 2 plus n pi. And to be picky, we'll say this kind of stuff. N's an integer. But if n's an integer, do I need the minus? Because it can be minus 1. Yeah, sure, but it's kind of redundant. I already got it covered, right? Okay? N can be a plus 1 or n can be a minus 1. I don't need to put plus. I might have wrote that before. I might have. Did I?
Yeah.
You have a, okay, okay. So, yeah, sure, but it's kind of redundant. All right. What did I say about graphing cosecant? Forget about the Math 11 stuff. What do? Take a maximum and flip it. Okay? Take a minimum and flip it. We just need to keep track of where my asymptotes are, but remember, the asymptote is where this function is 0, which is there and there. Okay? So it's kind of simple if we kind of just try to memorize it. Kind of makes a pretty picture, doesn't it? Okay, so what's the range of secant here? All the values of y greater than, that should touch that point, or equal to 1 and less than or equal to -1. Same thing. Okay? What are the x values of the green lines? Everything except those ones, right? And wouldn't you know it, those are my asymptotes too, right? Where n's an integer. Okay? So that's a basic graph. Graphing with all the transformations. So this is on our quiz here. That's not. Oh, that's not, sorry. Oh, sorry. The cosine and the sine is, but not these guys. Okay, so some helpful tips. Graph the basic shape. Graph the sine cosine, right? Graph it. Deal with amplitude, vertical displacement. Do period change. Do phase shift. Okay, hopefully we know what we're doing there. Then we're just going to, this is what this says. Just take the reciprocal of where the max and the min is. Because if we try to do our method in grade 11, it's really, really confusing. And when you guys get your provincial exam in this course, they will ask you questions maybe that are just multiple choice. Why? You don't have a provincial exam in this course? That's how old these notes are, but they still apply. When I was a boy, math 12, chemistry 12, physics 12, English 12, the first semester, and in the second semester, math 12, chemistry 12, physics 12, English 12. Well, it was twice as hard when I was a kid. Okay, yeah, you don't have this anymore, do you? Lucky you. Okay, so first, secant. Are we talking about sine or cosine? First, I want to graph that, okay? Now that may be a question on your quiz here in a couple minutes. Pay attention. What do I want to do first? I want to do that. That's the midpoint of where this thing is. And then I want to do that. The amplitude from that dashed line, the midpoint, goes up 3 units and goes down 3 units. Okay, that's the boundary lines, the max and the min of where this guy is. What's the period?
2 pi.
It's 2 pi. Yeah. Okay. It's cosine. And I don't have, what else don't I have? I don't have a phase shift. And I don't have, what else? Okay, there's my midpoint. Okay, so I'm going to start at maximum 3. And 2 pi later, I'm back at 3. Halfway in between, visually, that looks like about half. I'm at a minimum. Halfway in between there and there are my zeros. So when I'm graphing a reciprocal, what do I know about my zeros? That's where the asymptotes are going to be. Okay, that's y is 3 cos x plus 1. Now why can't we, I don't really need to say this, I just told you how to memorize to draw the graph of secant here, but the reason that you can't do that 1 over thing is because this isn't 1 over that. What you want to graph is this. Okay, and that gets a little confusing. It's not 1 over the whole thing. It's just 1 over that part. Still times 3, still plus 1. So all we're going to do, oh, I should have done that in blue, darn it. Now I'm going backwards with my colors. Where's my asymptotes? Got one there. Got one there. Take your maximum and just reflect it. Take your minimum and reflect it. Okay? Not much to it. Just graph the reciprocal to max and min. That's what we're saying there. All right? Amplitude was 3. It still is. Okay? It's the same. Vertical displacement, up 1. The same. Period, doesn't change. 2 pi. Phase shift, I don't got one here. Domain, everything except where I have these asymptotes. Now where the heck was that? That's half a pi. That's halfway between 1 pi and 2 pi, so it's 1.5 pi. So every pi over 2 and n pi's. Okay? What's the range? And we just want this one, right? I plot this, but it's not asking you the questions for that. It's asking questions for this. Y values are including 4 and everything above it. All the values of y greater than or equal to 4. And what's this point? There's 0. That must be -2. All the values of y less than or equal to -2. And the asymptotes, just look at your domain. That's where the asymptotes are. Pi over 2, half a pi, 1.5 pi, 2.5 pi, 3.5 pi, so on and so on. That's how we can write that. Questions? One more. Let's give you one with a period that's different than 2 pi and a phase shift. Because this is easier. What's your period here? Yeah, right? We're being nice. So first I want to graph this. Cosecant is sine of 2 pi over 10 x minus 2 plus 1. Same procedure. Do that first. Do the amplitude next. 2 up, 2 down. Then your period, 1 complete cycle, is going to be how long for this guy? Period is 10, right? You want this to be a 2 pi because then the number underneath it is the period. There's 12, there's 11, there's 10. So that's where this guy, before its phase shift, will end up. Now, your choice. Do you want to graph the whole thing or just put the points in? I don't know what strategy you guys have been doing. Okay, because I know this thing has a phase shift here. This is sine, so it starts there. I'm going to put x's. It ends up there, halfway between 1, 2, 3, 4, 5. It's at a minimum. No, it's not. It's at a 0. Okay, halfway between there and there, 1, 2, 3, 4, 5, 2.5. It's at a max. It's at a minimum here, 1, 2.5. Okay, so that's it graphed without the phase shift, but I want to go 2 units to the right. So that's going to be there, that's going to be there, that's going to be there, there, and there. Okay? That part's on your quiz. So don't try to figure anything out. How do I graph cosecant? Here's where I have a 0. I know it's not 0, but according to this graph, that's where the 0 is. So flip that one, flip that one, and we're done. Okay, piece of cake. Amplitude, still 2. Displacement, still at 1. What's my period? Still 10. Phase shift, 2 right. Domain, everything except no pi's here. What's this stuff say? That's 2. That's 7. That's 12. How do I write that as a little formula? Everybody agree? Good. Yeah. Right? Does it work? Check it. If n is 1, I get that one. If n is 2, I get that one. If n is -1, I get -3, which would be the next line, right? Yeah. And guess what? That's your asymptotes. where n is an integer. I'm not even going to write it, okay? Range, 1, 2, 3, and y less than or equal to, where the heck's this guy? Minus 1. Okay, not so bad. See, once you know this stuff, then cosecant's easy. So you guys got one more lesson. That's it. That'll be tomorrow. That's tangent and cotangent. Okay, test on a Tuesday. Oh, assignment. They actually, numbers 1 to 4 is more like chapter 4 stuff. Because remember, some people will have a chapter 4 and chapter 5 test all together. You remember the handouts I gave you? Okay, so 1 to 4, that's more like chapter 4. So I would suggest do that for review before your final in 4 weeks, 3.5. All right, so all we want to do for this test is just number 5, these graphing, okay?